Okay, and our bottom of the third page of the notes for 6.1, wrapping up this section, gives you an example of what you'll see in the application exercises. And we mentioned earlier that many times you'll want to, instead of just going straight to the number in the book, well, here it's number 104, look above it because there's some additional information. In this case, there's both a graph as well as some models. And again, review for Math 60. The graph would be representing the real data, the real measurements that they took. Okay? The models are the mathematical formulas that basically approximate what the data indicates. The data sort of indicates here, you can see the growth kind of headed up like this, kind of feels like the parabola we saw earlier. You can look at that orange set of data and it kind of feels like it approaches this kind of look too. So what they've done is they've mathematically created a model, a formula, a mathematical equation that approximates this curve. Okay, and notice they have the x squareds involved so that you can get the idea here of what we're doing with quadratics when you have x squared and you're trying to graph them. So let's look at what the first equation says. So that's the data. Here it describes the polynomials. Here are polynomial models that describe the median annual income for men, M. So this is men, this is women, who have completed X years of education. So X is equal to our years. Let's see what they ask us to do here. Use the equations defined by polynomials of degree 3 to find a mathematical model for M minus W. So they want us to use the degree 3 polynomials, which these are the ones that are degree 3 down here at the bottom, to find a mathematical model for M minus W. So as soon as they use the word model, you know that you are ignoring the graph. Okay? So model means that you ignore the graph for now. And you use the formula that they give you. Use the algebraic version. Okay? So in this case, we're trying to find M minus W. So part A, and I'll give myself plenty of space here, so I'm going to start up top here. Part A has us find M minus W. In this case, M is negative 18x cubed plus 923x squared minus 9603x plus 48446. I'm just copying straight from what they give us. And then we're going to subtract this second polynomial here, the 17x cubed minus the 450x squared plus the 6392x minus the 14764. Okay? And similar to our practice plus in the previous video, we are going to distribute that negative across all three. When you subtract something, a group of things, you're actually subtracting each piece. So instead of the subtraction sitting out here, we're going to apply it to each of the pieces inside here. So this becomes a plus and it then applies itself to each one. So this becomes a negative 17x cubed, this becomes a plus 450x squared, this becomes a negative 6392, and this becomes a plus 14764, and then we're able to add these two together. And when you do, the negative 18 minus 17 gives you a negative 35x cubed. The 923 plus the 450 will give you a plus 1373x squared. The negative 9603x and another negative 6392x actually gets you a negative 15995x. And again, I would guess you'd probably use your calculator on each of these. I have the advantage of having worked these problems already ahead of time, and then when I'm presenting them on video, I'm not pausing to grab my calculator because I've already worked that out in my earlier set of notes for myself. But it might take you a while to punch those in, or if you want to get really good and strong in your arithmetic skills, you might take a couple extra minutes and do it by hand. And finally, you've got your 48,446 plus your 14,764. That gives you on the end there 63,210. Sorry about the small squished handwriting, but your final answer for part A is negative 35x cubed plus 1,373x squared minus 15,995x plus 63,210. That plus is hard to see. Let's do it just one more time. See if I can get it just a little bit clearer. Numbers closer together. So that you can see that last piece, 63,210. Okay. Now part B says, according to the model in part A, so we've come up with a new model here in part A, what's the difference in the median annual income between men and women with 16 years of education? So this represents, this model is now, this new answer is now a model of the difference between men and women. So now we don't have to take the 16 years and plug it into men, then plug it into women, and then subtract. We can plug 16 into our answer for A. So what that looks like is we've got our negative 35 x cubed plus 1,373 x squared. Notice I'm leaving the x's out and leaving space for when I'm going to put in my 16. 15,995x plus 63,210. Okay, so then so I just left out the x, and now instead of x, I'm going to put in my 16 for x, 16 years, because that's what they asked for, 16 years of education. Okay. And again, I have done the math ahead of time. You're going to do the exponents first by order of operations. So you take 16 cubed and then multiply it by the negative 35. Take 16 squared and then multiply it by the 1,373. The 16 multiplied by the 15,995, and the 63,210 gets added on at the end. What you would get is that the difference, your answer for B then, is going to be $15,418. So just in the interest of space here, I'm going to assume that you're going to be able to successfully plug that into your calculator. If you're unsure, make sure that's a question you get help with. Note that and take that to your help resource, or bring it to us in class and we can look at that to make sure you know how to put those numbers into your calculator to get the same answer. Part C then says, according to the data displayed on the graph, so now we're going to go back to look at the graph on the previous page. What is the actual difference in the median annual income between men and women with 16 years of education? So actual difference. So when you look at the graph for part C, and it's very hard to see on the notes, you may have to go back to the book to see those actual values. The graph amount is 15,539, because you'll actually take the number for you'll go to 16 years and you'll take the number for men, subtract the number for women, and you get 15,539. Remember, this is the real data. This comes from the real data because it comes from the graph, as opposed to part B is the information from the model, or from the formula or the equation. Okay, so this is more the approximation. So then it makes sense why they would ask the next question for part C, did the model in part B underestimate or overestimate this difference, and by how much? So you compare B to C, compare the model to the graph. Your model is your answer in part B and your graph is your answer in part C. And B underestimated the real data. And by how much? Well, you would subtract the two, and you would come up that it has underestimated it by $121. Which, in the world of mathematics, the next question is that a good estimate then? Well, when you're talking about tens of thousands of dollars, 121 off, that might be a pretty close estimate, depending on what you're really trying to find out and study. Okay? And that takes care of 6.1.